Hello Year 10 and welcome to our final lesson of the week. I am Miss Goodwin and I'm going to take you through our last lesson. So far this week we started by looking at area of sectors, moved on to arc length. Yesterday we looked at cylinders. Today we're going to continue again along that theme of circles and consider spheres, cones and also look at some pyramids. To start today's lesson, can you go ahead and pause this video and have a go at the do now and come back for the answers in a moment. Okay, I would like to look at two questions in particular. This one down here, this relates to what we did on Monday. So if you don't understand this one, please do go back and have a look at those notes. You need to remember the formula that we use for the area of a sector. That was to express the sector as a fraction of the circle by using the angle out of the total number of degrees around a point and multiply that by the area of the whole circle. And that was our formula. What we do next is substitute in. We get 30 over 360 multiplied by pi multiplied by r squared. R is the radius, which is 9, and that's squared. Simplifying this fraction, I get 1 over 12 multiplied by pi multiplied by 81. I want to combine the fraction and the number now, and leaving pi on its own. So I've got 81 over 12 multiplied by pi. Now this is in terms of pi. The only thing I would want to do is simplify that fraction. We can take out a common factor of 3 from the numerator and the denominator, which is going to give me 27 over 4 pi. You could give that as a mixed number, you could give it as a decimal, but it's perfectly fine as it is, and that there is your answer. I've included a few questions this week about equations of lines, both parallel and perpendicular to, and hopefully if you were unclear on any of the answers, you've gone back to the notes from your lessons in school before you went home. For a perpendicular line, we want to find a gradient, which is the number next to x, otherwise known as m. So we've got y equals mx plus c. We want that m to be the negative reciprocal. What that means is if m is 3, I need to flip the fraction. Now remember, this could be written as 3 over 1. That's the same as 3. I need to flip the fraction for my new gradient. That's the reciprocal. And then I also need to make sure that it's negative. So a perpendicular line to this is going to be anything with a gradient of negative a third and then plus any c. You could even leave it as 0. You could have it as 4, 5, anything. So that's why often you'll see my answers for these questions with C, because that C can be any letter. Okay, here are the answers to all of the questions. Okay, to start today's lesson, can you please write down today's date and title? Okay, our first key point for today is that for a sphere of radius r, so that's from the very centre of the circle out to the edge, surface area is found by 4 pi r squared, and volume is found by 4/3 pi r cubed. Can you please pause the video here and write these down into your book? Okay, we need to be able to use these. So my two formulas were surface area is 4 pi r squared and volume was 4/3 pi r cubed. Okay, both of these answers are wanted in terms of pi. So for surface area, we're going to have 4 times pi times r squared. Well, r is 9. This gives me 4 times pi times 81, which is the same as 324 pi. It's a surface area, that's area, so we're going to be in millimetres squared. We started with millimetres, we finish with them. For volume, we're going to have 4/3 multiplied by pi multiplied by 9 cubed. 9 cubed gives me 729, so it's 4/3 times pi times 729. Finding 4/3 of that number gives me 972 pi. We're talking about volume, so we're going to be cubed. We started with millimetres, so we finish with them. And that is your answer. Can you please pause the video here and write that example down? Then have a go at the one on the right on your own. Notice how in this question here, for the volume, I don't change that fraction. I just leave it as 500 over 3. If you change it to a decimal, it's not very accurate. You could, if you wanted to, give it as a mixed number, but there's really no need for it. It doesn't ask you to, so you can leave it as is. Okay, can you please pause the video here and have a go at these questions? Question 1, you're giving it in terms of pi, which is what we've just done. Question 2, it wants it to 2 decimal places. That means that once you've done as far as we have just done in the 2 examples, you'll then pick up your calculator and type it in to get an answer. Please come back in a moment to check your answers. Please mark your answers. Can you now please have a go at finding the volume of these spheres? Again, the first one is in terms of pi. The second question is to 1 decimal place. Please mark your answers. Okay, our next key point is that the volume of a pyramid is 1/3 times the area of the base multiplied by the vertical height. The vertical height means it must be perpendicular to the base. That means it meets at 90 degrees. Please pause the video here and write this key point down into your book. Okay, so we need to be able to use this. So the volume of a pyramid is 1/3 times base times by height, where that height is perpendicular, or the vertical height. So to start with, we need to work out the area of the base, which is going to be 8 times 8, and I'm going to take 1/3 of that. And then I'll be multiplying by the vertical height, which is 10. This is 1/3 times 64 times 10, which is 1/3 of 640. Which gives me 640 over 3. There's really no need, unless they ask you to write that as a decimal or to simplify the fraction. That is a perfectly acceptable answer, as long as we have included units. We started with centimetres, so we finish with them. We have centimetres cubed. Can you please pause the video here and write down the example, then have a go at the one on the right on your own, and in a moment I'll start to solve it. Okay, notice here that I used 12 instead of 13. I had to use 12 because I needed the perpendicular height to the base. 13 is this slant, which would not have worked. Okay, please pause the video here and have a go at these questions. Please give your answers to 1 decimal place, which means you can use a calculator. And please mark your answers. Okay, finally we have surface area of a cone and volume of a cone. Surface area of a cone is given by pi RL, where R is the radius and L is the slant height, so it cannot be perpendicular, it must be the slant. And that's for the curved area. Okay, you also have a circle, so you need to work out the area of the circle as well. So if you wanted a full formula, it would be pi RL plus pi R squared. All you really need to remember there is that the curved area is pi RL, as you should already know how to find the area of a circle. For the volume of a cone, it's very much the same as a pyramid. A cone is simply a pyramid with a circular base instead of a square or a triangle, therefore it is the same formula. Please pause the video here and write down these 2 equations. Okay, let's look at an example now. We have pi RL for the curved area plus the circle, which is pi R squared. Substituting in what I know, I have pi times the radius of 5 times by L, remembering that L is the slant height, so in this case it's 13, plus pi times 5 squared. Simplifying this, I get 65 pi plus 25 pi, which overall is going to give me 90 pi for my answer. Please have a go at the one on the right after you have written down the example. Please make sure you include units. Okay, please pause the video here and have a go at these questions. We just want the surface area of each of the cones. For question 1, it is in terms of pi. For question 2, it is to 1 decimal place. Please mark your answers. Okay, you've made it to the end of this lesson. Can you please make sure you take a photo of your work and upload it to Frog using the file drop button. I hope you've enjoyed this week's lessons and we look forward to seeing you back in the new year.